And once again, welcome back to Notre Dame Day. I am Bob Montgomery. Our next guest is an assistant professor of aerospace and mechanical engineering and the principal investigator at Notre Dame's Wearable Robotics Laboratory, where he and a team of graduate and undergraduate students work together to research and design the future robotic prosthesis as well as exoskeletons. Welcome to Notre Dame Day, Professor Edgar Bolívar. Professor, thanks very much for joining us today. You are from UT Dallas. That's where you got your degrees. What brings you north to South Bend and Notre Dame?
Absolutely. Well, thank you, first of all, for welcoming here. I came to Notre Dame mostly because of the Robotics at ND group. So it's a group of about 50 people, including graduate students and faculty. All of us, we work in robotics. So that was appealing to me. Nationwide, it's not easy to find groups of that magnitude that collaborate in terms of robotics. So I found that was a strength. In addition to that, there was a lot of coherence in the offer. In the tenure track process, it could be challenging. It's a lot of time commitment. And so they gave us the resources to go there. So it was coherent with the expectation of high performance.
You are working in an area that actually has some ties to this region with the prosthetic industry based in Warsaw, Indiana, which is not too far from here.
Right.
But that's generally considered the more standard prosthesis. This, what you're working on, is very different. It actually has computational sort of applications, and it's essentially a smart prosthetic. Explain how that's going to work. What kind of impact could that have?
Well, for the person wearing the prosthesis, it's mostly about the difference of being active or passive, mechanically speaking. So it's about injecting energy at the right time. So once we lose our limbs, we lose the capability to have mechanical energy to lift our body up from seat to stand or going up in the stairs. And so we now provide the mechanical energy into the system so that we can help somebody stand up. And so that's the main advantage. By doing that, we want to improve kinetic symmetry so that your posture is better, you don't have back pain. We want to improve on metabolics, so you don't spend as much energy walking and so on. Those are those two very typical outcomes of what we do.
It also sounds as though with this particular smart device, for lack of a better term, that this will give more people an opportunity who may not have, with the typical prosthetics, an opportunity to perhaps walk when they would have a lot of difficulty doing that with the standard procedures.
Right. I have been very surprised. People with amputation above the knee or below the knee, they are completely functional in many ways. They play soccer, they do plenty of activities. I'm also joining a wheelchair basketball team, and they are amazing people in terms of performance. They outperform me in many ways. And so, yes, they can do a lot there, but they also have side effects. So your body is not meant to be supporting yourself in just one limb. And so the idea here is that in the long term, we improve the health outcomes by improving symmetry and so on.
It's not just a health issue, it's a quality of life issue,
right.
It sounds like. Yeah.
Yes, that's very important to us. It's in combination also with the comfort of the prosthesis. Having the motor is not going to solve the problem completely. You need to also think about the interface with the body. The socket, right now, the interface that we use to connect with the prosthesis is rigid. And so there are so many complications of that interface for that population.
So talk about your desire to get into this very, very specialized field. This is not necessarily something that people would immediately say, oh, I'm going to do this. This is my area of specialty. What led you to this path?
Early on, I started working in robotics close to 15 years ago. And at that time, industrial robotics were meant to be arms. And it was meant to be a technology that would replace the workforce. And I love the technology, but every time I talk to everyone else, it was, oh, you're the person working on how to get me unemployed, sort of thing. So this is my way to say, well, actually, robotics could be very useful if we think about the human. So I was lucky to connect robotics with people, and that's a good intersection now, and that's why I find a passion.
Is this really the very start? We talk a lot about artificial intelligence these days. Over the last year, 18 months, it's really exploded onto the scene, and now it's everywhere. And there are some of those same concerns about potential threats. I imagine with wearable prosthetics, this is also in its infancy.
Yes. The sensors that we have, the motors that we have are basically new to the field. So we have a lot of things to do. In terms of the mechanical design, electronic design is a big canvas that we have. However, the fundamental rules have been there for centuries. And so Newton developed the F equals ma ground rule. And so taking advantage of that legacy and new data, I think we can do a lot more.
What is the future for wearable prosthetics?
we hope to reduce mass such that we become basically, people don't make a difference between a robotic prosthesis and a commercial prosthesis that is already in the market. So in 5 to 10 years, we should definitely think about just prostheses. Some of them will outperform in terms of the mechanical energy, but hopefully we can blend our robotic prosthesis with commercial products and people don't even think about robots anymore.
So specifically at Notre Dame, this highly specialized, very advanced lab, what is your goal for this laboratory?
We have multiple. In the mechanical design, we want to take advantage of compliance. So rigid structures that are now the default configuration for power prosthesis, they're not helping us to reduce the mass. So we want to make compliant structures to help reduce the mass. We want to make prosthesis more intelligent by using sensors that can inform about the whole state of the human through ground reaction forces, for example. So with sensors that are localized in the leg, understand the complete human system.
Amazing. It's amazing work, and it's happening right here at the University of Notre Dame. Professor, thank you so much for being with us.
Thank you so much.
We appreciate your time, too.